This microphone is recording the soundscape and all the different sounds from birds, amphibians, and then the data are uploaded to a cloud system, and there we can then analyze these sounds immediately.
To avoid biodiversity loss, you will first need to understand how much biodiversity you have. I'm on the shores of Lake Neusiedl in Austria, the home to a host of endangered species. Now, a new system is in place to keep track of them by listening to their voices.
The reed belt area is, for me, is really a fascinating habitat, because from the vegetation side, from a vegetation point of view, this is more or less a monoculture.
Arno Chimaden is a ranger in the Lake Neusiedl National Park and manager of its biodiversity monitoring program.
Migratory birds in spring, they come to the breeding grounds, to Lake Neusiedl, to the reed belt, for example, and they want to get a very nice spot for breeding. And so the first birds, the first males who arrive, they are able to choose the best spots. And so in theory, you would hypothesize that the best territories are occupied first.
But keeping track of those early arrivals and all other inhabitants of the reed beds involves a mix of human expertise and technology.
So is this a sampling site?
Yeah, this is one of our sampling sites with the edge devices, and they are collecting the sound of this area here. We can just collect these devices with the stick. Up. And there it is. And the device is in here in this bag. And we have set it up so that it collects 1 minute sample every 10 minutes. So this is basically the whole device. So it's the battery, and this is looks quite simple. You see this little hole, that is the microphone. And on the other side of the device, you see at the moment this red flashing light. So this says that now it's recording, and when it then stops recording, then you will see a green flashing light. And this is the SD card where the data is then stored.
This is recording 24 hours a day.
Yes, exactly. So it's recording for 24 hours a day, but only 1 minute every 10 minutes.
So how many hours of data would that be in a month?
So it's 144 minutes of files per day, and then you can do the calculations. So in a month it would be then times 30, something like that. But all together with all the 60 stations we have here in the reed belt, collecting such a lot of data, we are up several terabytes already on data.
So there were 68 devices like this?
Yes, set out in the reed belt.
So what's the next step?
So the next step would be that we have to connect or to say to the device that it is deployed, it is set up at that site. I have here on my phone an app. It's called the Companion app. I can just say we want to add another edge device and set the deployment site. And this site is called BN04.
What's BN?
BN is burning site new. Oh. So that's the site where the last fire was 2 years ago.
So how come you get burning in a wetland?
Well, if you look at the ground here, it is dry. So the structure, which is just laying on top of this soil, is completely dry. And also the old reed stems. This is just in wintertime, it's completely dry. So it burns very, very easily. But from an ecological point of view, fire in the reed belt is nothing bad. It depends all on the time of the year. Of course, if you get a fire in the mid of breeding season, that is worst case scenario for all the birds. But the fire in wintertime, that is good, because then you get a new disturbance in these reed structures, and so the reed is also a bit pushed to grow again faster and bigger. And so that is also one way how you get different kind of structures in the reed belt.
So it can be good for biodiversity?
It can be good, and from our point of view, it should be even implemented as management strategy for the reed belt. So now we will collect the data, take the SD card with us, and put a new one in so that we can deploy it and put it back in the field.
So this will now start another 3 months of recording.
Yes, exactly. So we will pack it up again and put it up there, and then I will be back in about 3 months collecting the data.
Monitoring the use of such a dynamic ecosystem needs dynamic monitoring tools. Catherine Ryder works with technology company Huawei, which has provided the monitoring equipment. Wow, so Anna, what do we have here?
This is one of our guardians. It's actually a very cool device because it's more or less autonomous. So we have here the solar panels so that we get the energy supply for the device. Inside this box we have the batteries, and then with this microphone the device is recording the soundscape and all the different sounds from birds, amphibians, and with these antenna we get the connection to the mobile network, and then the data are uploaded to a cloud system, and there we can then analyze these sounds immediately.
And so where does this idea come from?
It was developed together with Rainforest Connection originally, and there was a cooperation. Originally the idea came from the rainforest in terms of illegal logging or hunting, and so what they did, they installed this kind of devices and had directly the message to their mobile phone. There's an app and they can see, okay, there is an incident happening out there, and then they can take the team and the rangers and drive and check what is happening. So that was also one of the reasons why they developed that. And together with the technology development and with the idea of Huawei, together they produce this kind of devices.
So what's the benefits of having it recording 24 hours a day?
Of course, you don't lose anything. And the other thing is that especially what we still lack for our area here, for the reed belt, we lack a lot of information what is going on during night and what is going on during the non-breeding season. So we would really like to see which species are actually using this area in wintertime, for example, and also what kind of activities we can detect during night. This is still a bit a black box.
So how many AI guardians are here in the area?
We, within this project, together with Huawei and Rainforest Connection, we have 2 of these devices. One is here in the reed belt and the other one is then in another spot of the reed belt. But our main focus is using these offline devices, the smaller ones, which are for our purpose also very ideal.
When we started our cooperation, you told me how you did the monitoring before.
Well, that was and still is labor intensive because we went into the reed with a big ladder, and then you climbed up the ladder, and then we were just listening like the device for 5 minutes which birds are calling and how many of them. What ears of people can do is we have 2, and so we can hear stereo, and with that ability we can also detect the distance of a bird species and also how many different individuals of the same bird species. This is so far with this technology not so easily possible. So we do not get rid of all the scientists in the field, but this is a very nice additional way of gathering data, because sending people 24 hours over the whole year, that is not possible.
The reed belt is a unique ecosystem bordering other ecosystems and must be managed appropriately. If I'm going to understand all of that, I need to overcome my fear of heights.
Here you have a nice view of part of the Lake Neusiedl, and in this area here we have a big enclosure, and there we keep Hungarian grey cattle and even water buffaloes. They are very important here because they are our co-workers for nature protection, because they manage to push the reed back into the lake and create, as you can see here, these open areas with open soils and also salt-influenced soils, where you see these reddish plants, where then really special plants can grow which are adapted to soils. And these are also areas which are preferred by birds. For example, the grey-legged geese, they really like these open grasslands with low vegetation where they can feed and grow their young.
So why does Huawei want to be involved in a project like this?
Huawei believes that digital technology is helpful for the society, for companies, for every human being, and also for different species, because technology can help in terms of sustainability to protect the environment and to help societies in different fields.
Many would say this is just a big company greenwashing. What do you say to that?
No, I can definitely say it's not. Huawei has a clear strategy in terms of sustainability. One is in terms of education, and also in Austria have different projects for the educational reason. We also have the environmental protection, where Tech for All is one of the biggest part, and we are also part of that here. We also support a lot of startups, not only in Austria, but also in other countries worldwide.
This project has been in place for a year now. Are you happy with the results?
Yeah, we are in the middle of the project now. As we have collected over 1.4 million sound files, that means we are now going into the analysis phase. And the plan is, through AI, the scientists here are able to match the different patterns of sounds and really to see the development of the species, like they have then the sound files, and they can do better analysis. They could not do that by themselves because that would be not possible to collect so many data in that time.
Overseeing the data collection and AI development is Dr. Christian Schulz from the Department of Botany and Biodiversity Research at the University of Vienna. You've got thousands of hours of data. How can you possibly go through all of it?
You can imagine when you would have to check all these sound files manually, but just playing them and listening to them, this would be extremely time consuming. We are using software able to identify species for all these individual sites which produce certain sounds there.
Can we hear one of the sound files?
Well, of course. We are using sound recordings of a length of 60 seconds, meaning 1 minute. And here, just within this relatively short sequence, you see a lot of different signals. And all these different signals are representing different bird species. Here we are. So now you can hear this song of the blue throat, which is not a very loud song, but very complex. Let's move forward to the common redshank. Very typical song.
So how does the system work?
So at the beginning, you really need bird experts of ornithologists to tell the software how the signal of a call of a certain bird species should look like. And then you are using this example to tell the software for what the software should search for within this 10,000s of sound files. And what you see here is the result of such a pattern matching for a very common species, the pheasant. However, not all of these identified sounds really are calls produced by a pheasant. So the software is not 100% perfect, and that's why you need expertise, because you now have to tell the software what is a true positive, meaning a correctly identified sound, and what is an incorrectly identified sound. But in the future, we would like to see that the software is getting better in identifying the bird sounds, so that's not necessary anymore to always need experts to go through all these files. And that's why we are now trying to implement artificial intelligence, machine learning, to improve this approach. So meaning we will provide to this so-called neural network, which we are using here, a lot of examples of calls, our target species, and this software will combine this information and will learn to more perfectly identify individual bird species from the provided sound files.
So why these locations?
The reed bed is aging and dying back, and this has negative consequences for this bird fauna of the reed bed, which is of high conservation value. So we have to think about perhaps certain management measures which will improve the situation again for birds. And one idea is to use fire management of the reed bed to renew the reed in a way to produce different successional stages of the reed. This means we have a kind of a time series ranging from very young reed areas, because there was a huge reed fire just 2 years ago, to areas which were burned 20 years ago, to areas which apparently were not affected by reed fires during the last decades. And a fourth habitat type, the transition zone between the wetland area, characterized by reed, and more open areas, for example, fallows, pastures, and so on. And this transition area is also extremely interesting in terms of conservation, because some bird species are really specialized to occur in this transition area.
And there's another type of transition area we haven't visited yet.
Usually we have higher water levels from autumn on towards winter and spring, and then during the hot summers the water levels decrease. The last years we had very dry winters, so the lake was not able to get refilled. And so in the summertime this year the water level decreased further down, and now, as you can see, the reed belt is completely dry. But this is nothing bad. It just belongs to this whole ecosystem, so that we have years where there's a lot of water and years where there's not less water or even drying out like now. And this area here is usually covered by water. And for example, in the soils then, once there is a water column above the soil, there is no good possibility of oxygen coming into the soils. And so under these conditions, it's very difficult for the reed to grow into these areas. Well, now it's dried up, and so now we have again connection with the air and soil, and so a lot of exchange of gases and also exchange of oxygen going into the soil. And now the reed gets the impulse to start growing also in these areas where it was not before. And actually you can see these are all new reed shoots which were just growing this year. And we will of course follow this process and see what's going on in the following years, if it will grow even more. And we will also see what happens when the water is coming back. So this dynamics in water levels is key for the whole ecosystem, and we should keep this dynamics as big as possible.